All right, now, so let's look at some examples of what are functions and what are not. So recall that a function is when each input has exactly one output. So we're going to look at these top ones here. Now, notice that the 3, plug in a 3, you get a 1. Plug in a 2, you get a -6. Plug in a 4, you get a 5. Every input has exactly one output, so that is a function. Let's look at this next one here. This one says that if you plug in a -2, you get a 1. If you plug in a 4, you get a 2. If you plug in a -2, you get a 3. Now, wait a second. That says that if you plug in a -2, you might get a 1 or you might get a 3. That tells us that it is not a function. In fact, I call that the universal not a function symbol. If you have something in the domain going to two things in the range, then that is automatically not a function. So here we're going to use a mapping. Mapping is one of the most easy ways to see what is a function or not. So the domain values are all the x values, and I list them in order, descending order, even though they're not the order that the points were written in. The range values are all the y's, or all the outputs. So then that is what all those numbers get mapped to. Now, based on the ordered pairs, we will draw the lines. And we never write values twice. So even though there is a -2 here and a -2 here, we don't write it a second time. We just write it once, and we'll draw the two arrows going to it. So that would be a mapping. And based on this mapping, there's no split from the domain to the range, so it is a function. Next. So here we can use what's called the vertical line test. If you're given a graph of the function, vertical line, if it strikes the graph only once, then it's a function. If any vertical line strikes the graph more than once, it's not a function. So here, a vertical line only hits it in one spot, it's a function. On this next one, we can see those two dots that are lined up. A vertical line will hit those two dots. That violates it being a function. Why? Well, that's because when x equals 2, it says that the y value could be -1 or it could be 4. Well, if we have a 2, that could go to a -1, or plug in a 2 and you could get a 4. That means it's not a function. Oh, I already wrote that. And then this one clearly violates, because in many places a vertical line will hit it more than once. So that is not a function. All right, and to round out this topic, let's look at function notation with a little application problem here. So x stands for minutes. The output is how many words. This is function notation. It's really the same as like y equals, but it emphasizes the input-output aspect of this. So this is just a name. That is not t times x. I know that if we did 2 parentheses 5, that would really be 2 times 5 is 10. Well, this is not that. All right? This is what you do over here. So this is the name. This is what to do. So when it says 7 minutes, we plug in x equals 7. This is the name, so this is function t, and what we're plugging in is a 7. What we actually do with that is substitute the 7 in for x on the other side. Then we compute and we get 455. So in the context, that stands for words. So 455 words in 7 minutes. On the second question, they give us the output value. We need to know the x. So we set up the equation. We substitute the 715 for the t of x, because that's the output value. And we back solve for what input would give us that. X equals 11 would work, and in context, that's 11 minutes.